Well, I'm out in the storage passage down the side of my workshop, and what we got here is a roller that came from a water break dynamometer that belongs to a friend of mine. He bought it many years ago, and it turned out not to be a going concern. There were two rollers which weren't properly balanced, and they weren't linked. Only one was actually coupled to the brake. They were mounted on these couple of bits of C-channel. You can see the outline of the holes that held down the bearing blocks, and at some stage he just cut the shafts in order to recover the bearing blocks, and had more or less abandoned the rollers themselves, and I ended up with them. And I've got two eddy current retarders. The little one you can see there is off a Mercedes Sprinter, and the one hiding under the front of the Cagiva Freccia frame is off about a 5-ton Mercedes bus. And so the shafts have been cut more or less flush with the ends of the roller units, so I plasma cut them out, and then the challenge was to get the end plates remachined, and I was intending to fit weld-in taper locks. So I've got a setup. Now I don't have a lathe big enough to spin these, to machine them. I did take them to a friend of mine to look at, and he was prepared to take it on, providing I removed the shafts first. He's got a big toast lathe that should be capable of getting hold of them, but there's a certain amount of hassle with taking it over there, and it's a not a particularly cheap job to have done, and it's kind of, yeah, it's you, so I'll do it, but it's not a job you'd normally volunteer to take on. So I have come up with a method to do it on the milling machine, and I think it might actually come under the category of stunt machining, either that or just of shady practice, but let's go and see what I've come up with. Okay, here's the second roller, which I've cleaned up very thoroughly with a wire wheel, and the plan is here. So I've got part of a right angle adapter. I've got a Vertex R8 right angle drive, which I bought cheaply from the clearance table at Kronos Tools, and the reason it was cheap was the inner parallel diameter in the output drive is undersized, so that R8 fittings won't actually go in. So that's that. Oh, I've had this for quite a while, and I finally took it apart the other day to think about getting that piece ground to fix it. And because I had kind of had the idea that I could use the right angle adapter to mill the end of the roller. Then I was looking at what I had left of the adapter and realised that I've got a nice flat face here. And up in my office, I had one of these Chinese high-speed spindles with a mounting block on a CNC router. And I've simply cut a plate and bolted it through to clamp it at 90 degrees and brought the VFD down and quickly programmed it to accept manual commands again rather than over the RS-485. Now the slightly dodgy bit, or perhaps very dodgy bit, is a pair of the shafts that I intend to mount the rollers on. And somewhere around here I've got one of the taper lock hubs. This is one of the welding hubs. Dunlop brand, not terribly expensive. And having cleaned up the cylinder, I realised the outer diameter is actually pretty clean. It's got some rough patches and little pits, but it does appear to have at one stage been turned. And I set this pair of shafts up on the C channels outside and just rotated the roller on them with a dial gauge, and I wasn't getting much variation on the diameter, so it was running pretty true. So raided my stockpile, found this solid square stock, and I had a couple of pieces. So the shafts are set up parallel to the table and parallel to each other. And the tip of this clamp, which is also clamping down the two bearings, and then I've got G-clamps the other side, that runs on the end plate to position it in that axis. And this is what I'm going to use to machine out the end plate to take the taper lock bushing, and we'll see how it goes. Okay, here we go. You can hear the fan of the VFD running in the background, and I'm going to drive the cylinder by rotating the shaft because I can get to both ends of it, which means I can get a smooth drive. So, wish me luck. Just 0 to DRO. Coming 0.25 millimeters. Clearly some run out on this end plate. 625. This is a 5mm slot drill. close to breaking through now. That is through with that section. Well, pretty rough setup and a little bit abusive of the cutter, but it wasn't a particularly good one. I'd hand sharpened it, but we got the job done. And the next stage will be to change the cutter to a 4 flute and take that diameter to size. There's a close-up of the finish. It's really not all that bad, and yeah, the cutter's a little discoloured, but it was before I started, and it's still reasonably sharp, so I am calling that very much a success. I'm going to change the cutter out and take it to final size. Okay, the hole size I'm aiming for is 90mm, and what I've got at the moment is about 85.55. Now, having been spoilt by having a DRO on the lathe that's direct readout, I have to be careful to remember that every cut is doubled doing this with the mill DRO. So I'm going to come across a millimetre and I'm going to take it in millimetre passes, and I've now got a 1/4 inch 4 flute in there. Excuse me getting in the way of the camera. Okay, that's slipping on the rollers now, so I'm going to go down to a 0.5 millimetre depth on diameter, that is. I'm going to continue making passes until I reach my final diameter. Well, we should be down to our last pass. I've got to take out 0.1 millimeters on the diameter. I'll dial up 0.5, and I should be able to take this in one pass. Try the tape a lot. Actually, I would say that is absolutely spot on. So, job done. Success, even with a rather oddball and precarious looking setup.